Let there be light.
Welcome to BruBuilds, your place for DIY home improvements. I'm Paul. I want to add some ambient lighting to our pergola, so I'll be installing some LED strip lights. Now, I don't want to see the lights themselves, so I'll be mounting the lights on top of the pergola beam and then reflecting the light off the ceiling, and then that should give us a nice soft light glow. I hope it works. Let's light this. I want all the wiring for the LED lights to be hidden, which requires me to drill and notch some paths for the LED tape and wiring. While I was working on the roof and cutting some of these paths, I realized it would be much easier to mount the LED tape now before I add the roof. But I don't want this stuff to be exposed to the elements, so I'll need to get the roof on quickly. But that'll be another video.
Tools and items needed: LED strip tape, LED controller, a power supply, LED remote or app, multi-conductor cable, low voltage power cable, wire connectors, wire cutters and strippers, a lighter or heat gun, a 1/2-inch wood drill, a Dremel tool, a small screwdriver, a utility knife, gloves, and your personal safety gear.
There are a lot of options when it comes to LED strips. Voltage, color, spacing, even the chip itself will affect the output and the look of the LED strip. Knowing the look I was wanting, and after doing some research, I ended up purchasing the BTF RGBW 4-in-1 LED strips.
On the Bru scale, technical ability I rate between a novice and an expert. You need an understanding of basic wiring and electronics. Physical ability I rate as easy to difficult. Depends on how much access you have and where you're installing the lighting. The electronics for the LED strip lights will be located under the barbecue behind the access door. To get the power and signal to the top of the 4 beams, I ran some 22 gauge 5-conductor wiring up to the fireplace structure through a hole in the cross beam, and then put the wires in a piece of metal conduit to protect the wires. I did all of this at the same time when I installed the 2 lights for the barbecue. LED strip lights use 2, 3, 4, or 5 wires depending on the type of LED, which is why I ran this 5-conductor wire. Now, there are some LEDs that use 6 wires, but I knew I wasn't going to use those. An LED strip tape system has 4 different components that work together to produce the desired light output. You need the LED strip tape, a power supply, an LED controller, and some type of remote or app. There are a lot of options when it comes to LED strip tapes. You need to know how and where you're going to use them to make the best choice. The most important option to take note of is the chip density, or how many LEDs per meter. Less expensive tape will have fewer LEDs per meter, and you will notice the spacing of the individual LEDs when reflecting on a surface, which is how most LED strips are used. A newer FCOB strip tape encases the individual LEDs in a phosphorus gel, which helps blend the LEDs together, creating a spotless, more uniform light. But they can be more expensive and are not waterproof. Yet. Which brings me to the different IP ratings. IP30, the lowest, indoor only, to IP68 for underwater. They come in different voltages. Just note that whichever voltage of LEDs you pick, the controller and power supply need to match. The best thing about LED strip lights is they are available in different white and color options. White, which comes in a WW, a warm amber white, or CW, a cool bluish white, or both, which lets you set the color temperature between 2700 warm and 6500 cool. You can get a single color strip like red or RGB, red, green, and blue on one chip, which gives you a variety of color choices when you blend the 3 colors. There is RGBA and RGBW, which adds a warm amber white or a cool bluish white to the RGB chip. And you can also get an LED tape with a warm white, a cool white, and an RGB, either with a 5-in-1 chip or with individual chips. And then there's what I call a smart or programmable IC LED strip, which allows you individual control of LEDs or group of LEDs. I ended up purchasing the water-resistant 12-volt RGBW warm white 4-in-1 60 LEDs per meter strip, which means one LED chip is split between the warm white and the RGB. This is what it looks like. You can see the red, green, and blue lights turning on, and then there's the warm white portion of the chip. I'll put links to what I'm using in the description. I need to figure out how to get this connected to this. I did purchase some of these LED strip connectors, but in the past when I've used them, this is always where the failure would happen. And if I cut the ribbon and connector off the opposite end of this tape, I'll be able to use this connector, so if there is a problem with this strip, it'll be much easier to replace. I'm going to get everything connected down here first, make sure it all works together before mounting it on the pergola. The first thing I want to do is get the power supply hooked up and make sure that it is outputting the proper voltage. The power supply didn't come with a power cord, so I need to attach one to it. I found a cord in the garage that I can use for this. It already was missing the end. I just need to cut off the jacket about 2 inches and then strip the insulation off the wires about a 1/2 inch. These strippers have different holes for different gauge wires. This is a 16 gauge wire. If you're not sure of the wire size, use a larger hole first. If you go too small, it can break or damage the copper wire, which can lead to a failure. Also, when stripping wires, just squeeze and pull. You don't need to twist the strippers around the wire. There is a terminal strip on the power supply for connecting the wires. Green goes to ground, white goes to neutral, and black goes to load or hot. Loosen the screws and insert the wires in between the 2 plates or washers, not directly under the screw itself. Then tighten the screws. Double check green, white, black. I'll plug the power supply in and grab my voltmeter, set it to 20 volts DC, and check between the V plus and the V minus. We have 12.3 volts. Perfect. Now I'll hook up the 2 LED controllers to the 12 volt power supply. I have some 18 gauge speaker wire that I'll use for this, and it doesn't need to be very long. The power supply has 3 terminals each for 12 volts plus and minus. I'll attach the 2 power leads to the power supply, then connect the other end to the LED controller. Attaching the power wires to the terminal on the LED controller with the V plus and the V minus. Make sure your plus and minus are correct on both the controller and the power supply. The LED tape already has connectors attached to each end for attaching strips together. Since I'm using just 1 strip per beam, I don't need the connector at the end, so I'm going to cut it off and reuse it to connect the LED tape to the controller. Separate the individual wires and strip them back 1/4 inch. Each wire represents an LED color. Black is for power, then green, red, blue, and white. On the controller you have white, blue, green, red, and 2 screws for power. I'm using 1 controller for 2 LED strips, so I need to attach 2 wires to each terminal, except for the power or black wire can be on their own. Controllers have a max output. To figure out how many you will need, divide the max LED tape watts by the voltage. In my case, 120 watts divided by 12 volts is 10 amps. This controller has a 15 amp max output. Since I'll be shortening each LED strip, I should be okay with 2 strips and 1 controller. Double check the wiring: white, blue, green, red, power, and power. Now I'll plug in the 4 LED strips into the 2 LED controllers using the 4 connectors that I just added. And plug in the power supply. Yay! It works! There is a Smart Life app that can be downloaded to control the lights through Wi-Fi, as well as the wall-mounted controller. It was fairly easy to add the lights called devices either by discovery or manually. Once they are discovered and added, you can change brightness, color, and saturation per LED controller. Since I have 2 strips together in 1 controller, I'm changing them in pairs. I would need 4 controllers if I wanted to change the strips separately. I mentioned earlier that there are some LED strips where each individual LED chip has a separate control. I'm just wanting to add some ambient lighting with the ability to change color for different seasons. If you want that look, you need an IC programmable LED strip with addressable chips referred to as pixels. Be sure to note and compare the LED count and the pixel count. Sometimes we'll group LEDs together to make up a pixel, which means a group of LEDs will change together. So if it says 60 LEDs 20 pixels, it means they'll change together in groups of 3, not individually. This looks to be working just fine. Time to get it installed. Before I do, be sure to click on the like button and subscribe to BruBuilds for me. I marked the 5-conductor cable with tape when I installed it. That way I can pair the outside beams together and the 2 inside beams together. This end will attach to the LED controller, so I need to strip off 2 inches of the outer jacket. This can be done by bending the wire and carefully cutting the jacket with a utility knife. Once you get a cut around most of the jacket, you should be able to pull it off. Just be careful not to nick or cut the insulation of the individual wires. Now I can attach these 4 wires to the 2 controllers. Okay, white, yellow, which is blue, green, red, black, black. This end will be a little more challenging. I'll strip 3 inches of the jacket off to give me more wire length, so I can attach the 6-inch pigtail with a connector on the end. I purchased this box of new type of wire connectors online. I'll put a link in the description. These are a heat shrink tube with a solder ring in the middle. They come in different sizes for different wire gauges. I've never used them before, but these should work great for this application. To avoid ending up with a big clump of connectors when wiring a multi-conductor cable together, stagger the joints by cutting the wires at different lengths, which means on one end the black wire will be the longest and on the other the shortest. I've already cut the wire ends that have the connector. Now I'll match it up and cut the wires coming out of the beam. Strip a 1/4 inch of the insulation off each wire, and I'm ready to try out one of these new connectors. I need to make sure that the strip part of the 2 wires are overlapping in the middle between the solder ring. Let's add some heat. You can just see the solder starts to melt. That was pretty easy. 4 more to go. To get the LED strip tape through the 2x6 crossbeam, I marked and drilled a 3/8 inch hole, and to keep the tape flat, I used the Dremel tool to square the bottom of the hole. That way the tape will lay flat on top of the beam. I need to thread it through 1 more beam, then I'll plug in the power supply. This LED tape is rated IP65, which is safe for damp locations. The tape is waterproof, but the connectors are not. My plan is to face them up and reflect them off the ceiling, which is why I was wanting the adhesive backing. I couldn't find a tape with a higher IP rating that also had the adhesive. Seeing how it's reflecting off the OSB plywood, these will work great at adding some ambient lighting to the area. The roll is longer than the beam, but you must cut an LED tape in the correct spot. It is where the white line goes through the copper ovals. To go around a corner, you would cut it in one of these spots, add a 90-degree connector, and then continue the tape down its path. I'm ready to start sticking these down to the beams by removing the paper to expose the adhesive backing. To hold the ribbon wire and connectors down, I'm using some plastic wire clamps. And trying to think ahead, added some extra wires for some more lighting in the future. One for a spotlight on the fireplace and one for light above the seating area. This should work well and create a nice soft light. I don't know if I'll ever do a rainbow effect, but they give off enough light that I'll be able to still do some work out here at night. This is what it looks like now with everything completed. I'm super happy with how they look and haven't had any issues with them. And it's been fun to be able to change the colors and add some festivity to the area. Thanks for watching, and check out the playlist on this entire backyard project. I also have a video where I added in some inexpensive LED down lighting for the barbecue. Be sure to hit the like button for me and subscribe to BruBuilds, your place for DIY home improvement.